Hi everybody. So today we're going to talk about angle relationships specifically in polygons. And remember that a polygon is any enclosed shape. So any enclosed shape. So usually we need 3 or more sides to make that shape happen, okay? So it's any enclosed side shape. A regular polygon is now any enclosed shape with equal sides. So that means that all of the sides in that shape, so for instance, if this was a regular triangle right here, all of the sides in this triangle are going to be the same sides, or same length, sorry, with equal side lengths. Okay. All right, so let's go through this chart here, and you should have maybe found something kind of similar when we were talking about the sides between 1 and 10, or sorry, I guess it would be between 3 and 10. So if I have a triangle, I'm going to have one vertex. So remember that my vertex are where, actually, let's go over these words again. So remember, vertex means that it's where any of these sides kind of meet, okay, where any of the sides meet. So what I want to do with these vertex, see how many triangles I can draw with them. So if I was looking at the number of triangles that I could form from one vertex, I can only draw one of those. Okay, so I can only draw one of those, right? The sum of the interior angles, so if I were to add up all of the inside angles in my triangle, that's going to equal 180 degrees. And if this is a regular triangle, then that means that each interior angle is 60 degrees. And this is for regulars. Okay. And remember my exterior angle. So if I were to have this triangle and I were to draw my line out, if I know that this angle is 60 degrees, then that means that this one has to be 120 because of the laws that we learned. Okay. And all of my outside angles are going to equal 360. So remember that if I were to add up 120 from here plus 120 plus 120, that equals 360 degrees. Okay. So now if I'm looking at my square here, if I pick one vertice, so let's say I'm going to pick this one, I'm going to draw as many triangles as I can. So if I draw a straight line from that one, I have 2 triangles here. Okay. The inside angles of my square, those are all going to add up to be 360 degrees. Which also means that each interior angle here is going to be 90 degrees. So to find that interior angle, I'm just taking the sum, so the total here, dividing it by how many there are. And we know that the inside of a square makes 90-degree angles. So if I have 4 outside angles, each of my exterior angles then is also going to be 90 degrees. And I know that because if I were to draw that straight line here, this is a 90-degree angle, that's a 90-degree angle. Okay? The sum of all of those angles is going to equal 360 degrees. And in fact, you should be seeing a pattern here so that I can actually fill in 360 degrees for all of this. Okay? All right. So notice here that when I have my triangle, I know the inside of one triangle is 180 degrees. And then I said in this shape, I can draw 2 triangles. Well, 180 times 2 is 360 degrees. And notice in a pentagon, I can draw 3 triangles. Now that's 540 degrees. Okay, so I want you guys to pause the video and I want you to try to fill in the table based on the pattern that you're seeing. So I'm just going to go ahead and fill in the table and you should have gotten the same results. As I'm filling it in, you should also see that the number of sides here and the number of triangles I can see are -2. So 6 minus 2 is 4. 4 minus 2 is 2. 5 minus 2 is 3. 7 minus 2 is 5. So if I'm going through and filling this in, if I have a 12-sided shape, instead of having to draw all these triangles, I just subtract 2. So I know that that's going to make 10 triangles. A 20-sided shape, okay, that's going to make 18 triangles. Okay, So if I had an n-sided shape, like an infinity amount of sides, all I'm going to do is n minus 2 to figure out the sides, okay? And like we said, we're going to take this number that we found here, times it by 180. Okay, so now I'm going to do the number of sides times 180. So 4 times 180, 5 times 180, 10 times 180, 18 times 180. And then this would just be n minus 2 times 180. All right. Each interior angle is going to be the number that you got here divided by the number of triangle or the number of sides that you can make. All right. So, excuse me, if I'm looking down here at this one right here, right, I'm going to have my n minus 2 times 180 formula. I'm going to divide that by n at the end, the number of sides that I have. Okay. All right, so let's move on. You guys should be able to fill in this table. I'm going to pause the video and fill it in for you, but you should be able to do this on your own. Okay, so here's the table and the summary of kind of everything that's going on. So let's just look at that last column again. Remember that in order to find the number of triangles that you can make, it's n minus 2. And then in order to figure out how many degrees are going to be inside of that shape, so the sum of the angles inside, you're going to do the number of vertices that you have, so n minus 2, times 180 degrees. And then if we need to figure out exactly how much each of those angles are, you're going to take that number, divide it by n. Our exterior angles, those angles on the outside, that's going to be 360 degrees because they always add up to be 360 divided by the number of sides. Okay, so let's just run through this summary super easy, super quick. So remember that the sum of the exterior angles of any polygon, so those outside angles are going to add up to 360 degrees. Remember that any polygon with n sides is going to, the sum of the interior angles is in degrees is going to be n minus 2 times 180. Sorry, times 180. N minus 2 times 180. For a regular polygon where all the sides and angles are equal, these rules apply, okay? So really this is like the important part of what we're talking about here. So a convex polygon is any polygon that has interior angles that are less than 180 degrees. Basically what happens is that you can draw this so that if I was looking at something like a pentagon, all of my kind of angles here are pointing outwards. You guys see how they're all pointing outwards? Whereas in a concave polygon, now I could have something like this, where this is still a pentagon because, look, I still have 1, 2, 3, 4, 5 sides, okay? So we just need to be very kind of understanding of these, because if I was in my convex polygon and this was my vertex here, I could draw a triangle. Actually, let's make this one my vertex, sorry. I could draw my triangle. If this was my vertex, I could draw 1, 2, 3, 4, 5. Okay, so I could draw 5 triangles there, or draw it across, right? So I could go 1, 2, 3. Okay. So again, I can do that here. 1, 2, 3, 4. It's going to be a little bit different because those angles now are inside different. Okay, that does make a huge difference there. Okay, so in this example, we have 15 sides, and that means that our n is 15. I want to know how much all of the angles inside of this shape are going to add up to be. So I'm going to use my formula, n minus 2 times 180. Okay, my n is going to be 15, so I'm going to replace that. 15 minus 2 is 13. And now I'm going to multiply that by 180. Okay, so all of the angles here are going to add up to 2,340. Now, I want to, in example 2, figure out how many sides are in a polygon if all of the angles add up to 5,400 degrees. So, and I just realized I should have a degree symbol there. And we're going to show our work. So I know that the sum of all of my angles is going to equal n minus 2 times 180. And I know that all of those interior angles, those are going to add up to be 5,400 degrees. Okay. Now, I want to figure out what n is, so I need to work backwards, just like if it was any other equation, to figure that out. So I'm going to undo the 180 by dividing both sides by 180. Remember, dividing is the opposite of multiplying. Okay. So now I'm left with n minus 2 on this side, and all of that's going to equal 30. If I'm subtracting 2 on this side, I need to add it to the other side. So then this means that I'm going to have 32 sides. Okay, so this is it for today's lesson. I hope that everybody is doing well. Miss you all.